Namaskar. Good evening to all. I respected Dr. Suresh Pal, Director, National Institute of Agriculture Economics and Policy Research. Our panel, Dr. Subhas SP, Dr. B.N. Mandal, Dr. Arpan Bhumik, my co-host, Dr. Abhimanyu Jajaria, and all dear participants. On behalf of ICR, National Institute of Agriculture Economics and Policy Research, I extend a warm welcome to you all. This webinar series is part of ICR National Institute of Agriculture Economics and Policy Research commitment for capacity building of social scientists from NIAP system. And for this webinar series, we have got overwhelming response from all of you, and it's very pleasure for us to share that more than 4,000 participants has registered for this training program. Now they are connected through Zoom as well as Facebook Live of National Institute of Agriculture Economics and Policy Research. Now I request Dr. Suresh Pal, Director, National Institute of Agriculture Economics and Policy Research, to give introductory remarks. It's over to you, sir.
Thank you, Dr. Vinayak. It's really good evening to all. It's really my pleasure to welcome all of you to this platform. And thank you for your overwhelming response to this particular webinar series, actually. This is third program, actually, we are conducting. First two programs we have conducted, they was face-to-face. And based on the experience of last two programs, we have brought out a reference book which the different researchers, they can consult when they are actually doing their research work. Now, based on the positive feedback we have received during the face-to-face training program, so we thought let's use this opportunity to have a seminar, or you can say the series of seminars on important topics of the methods generally the social scientists use in research. So with this background, we have just requested my colleagues to have around 20 lectures on important methods which are frequently used by the social scientists. And very carefully, we have selected the topics as well as the person who will be taking the, let's say, the speaking on this platform. They are really active researchers who have worked on that particular area. They know the theoretical background of all the methods, concept they can define very clearly. They can also share their experience when they apply these methods. So what are the things, actually practical things or the problems we face, maybe in terms of data management, in terms of application of software, maybe other things, and interpretation of results also. And they will be demonstrating one exercise that how particular method can be, let's say, applied, and what kind of results we get from these methods. So that is what we have in mind. So we have really senior level as well as the, I would say, the active researchers who are undertaking both from the discipline of economics and statistics and extension also, of course, who are using these methods. And they will be discussing this. And I'm sure the kind of response which we have received for this webinar series, so I'm sure all the participants who have registered, they'll be benefited from this. Number of methods we have chosen. The another advantage you have, it's not only the topics which will be covered, but the reference material is ready for you. You have all your test books in econometrics, statistics, but you have also now reference book which you can really concern and then see step by step how you can use those methods. So that is another added advantages this webinar series has. And I'm sure my colleagues, they'll be doing their best, and all the speakers, invited speakers, particularly from ISRI, so they'll be making best use of your time so that you learn during this time and you will be able to use these methods. One more thing which we have added, generally we do it because we explain the methods, we explain what kind of, let's say, the results we obtain, but we seldom touch the statistical softwares. So we have some exclusive sessions on statistical softwares where my colleagues, they will be discussing, as well as all the speakers, they will use the software, whether it is Stata or it is SPSS or SES, whatever the methods, or are, whatever the software they use it. So they will be actually demonstrating or sharing with you that how these softwares can be used for doing the analysis which you want to do. Friends, in social sciences, quality of data, quality of analysis, robustness of the results, they are extremely important. And with this background, we have designed this course. We are doing it third time. And based on the success of this course, maybe we can have a follow-up program, because the response to this program is very, very, say, encouraging. So again, thank you very much, and hope your next 20 days, they will be productive. You will have hands-on kind of thing, maybe experience. My request to you, yeah, that when the session is over, you try something, take some, let's say, data set, apply those methods which are of, let's say, of interest to you. And if you have any problem, you can get back to the, let's say, the speakers. Our effort is that we connect to the suitable person who is working in that area. You can always do exercise, and if there are problems, you can get back to the speaker, seek clarification, seek interpretation, whatever support you require. So that is the basic purpose of this series. And I'm sure with your interaction and the interest my colleagues will take and the speakers they will take, this program will be very, very useful for you. So with this, I thank my colleague for taking this initiative, and all other speakers who have very kindly agreed to take sessions on different topics in which they are working. Thank you very much, and all the best.
Thank you very much, sir, for this kind and encouraging words. Now, Dr. Abhimanyu, it's over to you.
So I take your leave now, Vinayak.
Yes, sir, sure, sir. Thank you very much, sir.
Okay. I have some people here. Thank you very much.
Good evening, all the participants. This is Abhimanyu, and now next our panelist is Dr. Subhas SP. He is working as a scientist in National Institute of Agriculture Economics and Policy Research, and he will be presenting on basic of Stata software. So now, please, Dr. Subhas SP, take over.
Doctor, please unmute yourself. Dr. Subhash, please.
Thank you, Vinayak sir. Thank you, Abhimanyu sir, for the brief introduction. Is the screen visible? Good evening, everyone. Thank you for joining for the session. In the session, I'll be briefly presenting, rather introducing the Stata software. From the starting, let me make it clear that the session is for beginners with an aim of introducing them to the software, basic software, windows, the menu, and the basic data handling operations. It's a preparatory session for the follow-up sessions in which the next 4 consecutive sessions are profit logic session. There's another session on impact assessment in which we are, the experts will be using PSM and DID Following that, there will be another session on panel data regression and instrumental variable regressions, which is following in next 4 days. Those experts would be using Stata software. So it's a preparatory presentation for those sessions too. If you have already used software and if you're an expert, this session is not exactly for you, but still you could attend the session, and I hope that we'll be getting some more further insights about software and the methods in which it's used.
डॉक्टर
If you
डॉक्टर सुभाष जी, मैं आई रिक्वेस्ट थोड़ा स्लोली आप बोलेंगे तो सबको आवाज जाएगी, स्पीड
Okay.
आपका.
if you have Stata software with you, you could work on the Stata simultaneously. Those who don't have the software, I would rather encourage to just watch the video at this point of time. This is also simultaneously telecasted in Facebook Live. The platform would be there, the video would be there for another 8 hours, so you could watch later and try it in Stata software simultaneously. We are also providing basic notes and data sets to work that would be shared with you. So you don't need to worry about the codes being used or the process being used. There'll be data and notes being shared with you. This is, again, let me point out that this is a very basic session, and I would encourage you to explore a lot of videos which are available in YouTube and the Stata help files which are available in Google. So in the session, I'll be covering a few topics. First is how to download the trial version for the class. Those who don't have the software, we'll be discussing why we need to learn Stata software, why Stata, how to work on Stata computing environment, how to get help and finding packages, how to use features such as do files and log files and why we need them, how to import data in other formats other than Excel, like Excel or CSV files, how to import those data into Stata, and I'll be demonstrating few basic operations. Let me put it out, Stata is a paid software. Those who don't have the software could download the trial version for a limited period. For that, you can go to Google and type Stata trial. You could see that two versions. One is evaluate Stata version and another is student short-term license request. Evaluate Stata version is for researchers, which would allow researchers and faculties, which would allow you to access software, Stata software for an evaluation period of 30 days. For students, the short-term license request is for 7 days. At this point, it is enough for the webinar sessions because within the next 7 days, we'll be covering those classes in which we are using Stata as an analytical software. There could be some delay in getting the trial version. You could see while applying for trial version, you need to fill a form. So I would strongly encourage those who have not downloaded the trial version to apply today itself, so that by the time for the next classes, you would have a trial version with you. Simply, you need to fill the details and apply for the trial version. So let's start working in Stata. Stata. One thing is that Stata is a statistical software package which helps in doing statistical and econometrical analysis. The question like why we need to use Stata, if you compare with the existing statistical softwares like R, SPSS, SAS, or Python, it has its own advantage as well as disadvantage. One is that R and Python are free access softwares, and rest SPSS and SAS are paid softwares similar to that of Stata. One advantage of Stata is that it's less complicated than R and Python. Like though RStudio has some good features which makes it less complicated, still Stata is far easier than R and Python. One more thing is that comparing it with SPSS and SAS, it's much cheaper and affordable even for students. Another thing is that it has a wide user base. It's widely used in international organizations, foreign universities. A lot of CGR institutes use it, like IFPRI, they use Stata as a key statistical analysis software. Again, they have a very good support forum. Support forums are like, if you have any queries, you can put those questions into support forums and they will help you with resolving those queries. That's the support forum for. The selection of software completely depends on the kind of research network in which you are working. So research work, when you work in networks, you should have people working in similar software platforms so that you can share codes and share your works. That's one thing. To just say, as of now, you may need to understand and require for the next 4 sessions. Let's switch to Stata and see how it works. So if you have Stata downloaded and if you have that in your desktop, you can double click it and open it. Or I have pinned it to the taskbar below in the desktop. So I'm opening it from the taskbar here. So this is how Stata environment looks like. It has mainly 5 windows. What I mean by window is that this is one window. This is called as a review window. This is a window where we get this output. This is a window which we call as command window. This is a variable window, and this is like, so properties of the variables can be seen in this properties window. We'll be looking into each of them simultaneously, how to work with it. In Stata, you can operate Stata in 2 ways. One is by typing the commands in command window. Another is going for this interactive UIs, or basically the drop-down menus. For example, if you want to do a statistical analysis, you can go to Stata, click the basic summary analysis, summary and descriptive statistics, and summary statistics. This is one way of doing analysis in Stata, which is which you can do it. There are few basic and most commonly used statistical operations. There is an outline and there is a path in which you can use this drop-down approach to solve it. For example, if I want to summarize it, I could go for summary statistics, click it, the window would open up. You could select a window variable for which we have to do summary and click OK. This is one way of doing it, or else you can just type sum and type the variable name and in which we can use it. Before going into Stata, the thing which people ask is like, we can also get help in Stata window itself. For example, we want to do a summary analysis of a variable and we don't know how to do that. So in the command window, this is where we type command. You can type help, summarize. So when you type help summarize and click enter, a new page opens up in which it shows the syntax. Syntax is like, unlike the drop down, you can also type the command in a fashion that you could get the same result. So the syntax for summarization of any variable is that summarize variable. Like you can add if conditions, like conditions to be added to it. You can also give weights if we are using large sample surveys in which weights are estimated. This is how it's done. So you can use help to find any command. Many times help may not yield the same results. For example, if you want to do factor analysis, if you type help factor analysis, you may not get any result. It may show that there are no matches. So in such cases, what we can do is that we can do a search from the command window. You can just type search and say factor analysis. So it would show up what are the packages or what are the syntaxes which we use for factor analysis. For example, here there is a package called as factor, which helps in doing factor analysis. There are basic statistical, lot of basic statistical operations are already built into Stata. If there are packages which are like, there are additional statistical analytical stuffs which may not be basically built into Stata, we can download it from other, they are called as packages. These packages could be used, which are like downloadable ASAN, which mean when we require it. So how to download packages is that you can go to help and search here. This is similar to that of you using a command-based search. You can go for help, keyword search. Here again, you can type factor analysis. It would return to the same page as we have done using the command. In Stata, the mathematical operations are similar to what we use in Excel. The logic operators such as like greater than or equal to, less than or equal to, if or and conditions work in Stata using the same logic. Let's start with importing a data to Stata window. So if you already have a Stata data, the extension of files in which data is stored in Stata is called as .eta, which is similar to .dox in case of Word, .doc in case of Word, or .xls in case of Excel. For example, if I'm having a Stata data file, so you could see the file extension is .dta. You can double click it and open that data. Other way of doing is you can open the Stata and go to file and open, go to the folder in which you have the data and you can open it. These are two ways of opening it. There are other ways of opening it. So if you already have a file and if you want to clear the file and reload it again, you can use the syntax called as clear. This is one. So what clear does is basically deletes all the data which is uploaded to the Stata. So you could see that when we are doing it by using the drop-down menu in the output window, you could see there are statements or syntaxes coming up. This is also the syntax in which if you want to import the data using syntax format. For example, you can also type use and the path. Path, this is what basically we call as path of a file. Path of the file denotes where the actual file is in the system. So how to get the path of the file is, this is a folder in which you have the file. You can just click here. This is one way of getting the path of the file. So this is a folder in which you can copy it from here. You can paste it, \. You can type down the name of the file, data file. You could see the file being imported. So you can also import the file using command. In the variable, you could see in what are the variables which are in that data file. This is a case where you have a data file and how to import that data file into Stata format. So there are multiple ways of doing it. You can use either the command to import it, or you can use the drop-down menu to import it. Let me show a case when you have a data file as Excel. This is a case where I have a data file in Excel. Now I want to import this Excel data into Stata. Stata allows to import data from other different formats. So this is a the Excel data file which is with me. You could see the first row of the data is the variable names, which we generally keep when you are developing data files. you could go to file and you can directly import. So there is an option in file. There is an option called as import, in which you can directly import the Excel spreadsheet. If you just click Excel spreadsheet, there will be another window opening called as import Excel. You could browse, click the file, and click open. It would open up. So as I said before, the first row is the variable name. So you can click this option. This is like import file row as variable name. You can click this option. So the first row becomes the variable name. You can click OK. This would import Excel file into Stata file. So this is how I've imported an Excel file into Stata file. You could save this file, save as. Now it would be saved as a data file, class data. So if you see in the output window, you could see syntaxes, simultaneously syntaxes being created. So one way is that you can define, you can type down, once you get used to it, you can even type down those syntaxes and use it. This is one way of using it. Another thing is that this is like directly opening a file. One good practice is that creating a, what we call as a directory in Stata. Directory is basically a folder based on which you can we can save the data. So I've cleared the data existing in the Stata thing. Now I have to set a directory from which, directory is a folder we are pre-assigning from which we can actually pull the data for analysis. So how to set a directory? You can use this command cd, then define a path. For example, I have a folder called NIAP webinar in desktop. You could see the path here. It's in C. You search Subhash desktop NIAP webinar. You can copy this path and set as a directory. So why I am using double quote is that if you have space in between this, for example, in my folder name NIAP webinar was created with a space in between it. In such cases, you need to use double quote. You can set a directory. This is CD. So once you have set a directory, you don't need to specify the whole path again. Rather, you can directly say use and the name. You can just type the name of, or rather copy it. Like you can use same name of the data file. So again, data would be open from the directory. So you don't need to. So once the directory is set, you can directly open without specifying the path every time. This is one thing. Two main features of Stata which we need to know. One is called as do files and another is called as log files, which are two features of Stata. What do files does is that you can save all this command. You can basically write this command a priori in a do file and run that command from all these commands like at a stretch from the do file itself. So let me just show you how to create a do file. One easy way of doing it is that in the top taskbar, you could see a icon with a notebook and a pen. If you click it, it will open a new window which shows this is the way you can open up a do file. In do file, for example, one thing which I like, one command, one statistical operation which I would like to do is basically summarize the data. So you can write summarize any variable in the data. Let me pick a variable which is summarize age, which is already there in data. So if I want to, I can write the command a priori, then execute using this execute command in Stata. That's one way of doing it. So if you want to make any notes, for example, quotes for Stata class, you could do it either by using a star or a double backslash. So what it does is basically it won't execute whatever follows that. So what you can do is basically save this do files. You can save it as, so it saves as an extension Stata. I'm naming it as Stata class .do. This is basically an extension for do file. That's how you save a do file. Another feature is called as log file. What log file does is that whatever we are seeing in this output, it needs to be stored somewhere. A log file is a file which records all the activity, what we are seeing, what we are doing, which would be like shown in the output window. One easy way of creating a log file is that you can click the icon, which is similar to that of a notebook. Here in the taskbar, you can just click it, which would open up a window asking for creating a new log file. The extension of log file is .smcl. So Stata, I'm just naming a log file Stata class log file. So what it does is that it starts logging all the operations which we are going to do after this. So this is a way. So if you want to go back and see what we have done, this is the place where all the operations are getting stored. Let me demonstrate a few basic commands. For example, if you want to do sum, in Stata, you can, as I said, you can either go by drop-down menus or you can just type the command. If, like, for example, sum, the basic like syntax is pretty simple. It's sum, and if I want to select a variable, you can either type the variable sum age, or you can just click from this variable window. For example, sum age. If you click the arrow here, it will automatically show. It will get shown in this command window. If you just type sum age and click enter, it would show the summary statistics of basically the variable age. Another way of doing is going to statistics, go to summaries, summary and descriptive statistics, summary statistics. You can select this variable age, then click OK. So it basically executes the same. Summarize, sum is a short form of the summarize age variable. This is how you can use Stata. These are the very basic commands in Stata. Just to get a feel about how the Stata works and how the Stata window looks like. Experts in the upcoming sessions would be sharing you this do files, which you can use it. So if they are sharing a do file, so I already have a do file here. If they would be sharing this do file, so how to execute a do file is that you can open a do file. You can specify the path, or you can just copy this. Paste it here. This is one easy way of doing it, or else you can execute directly from the do file. So for executing directly from the do file, you also need to define the path of the data. So once in your do file, the first thing is that this is the path in which you have the data, and next is the operation or the command you are going to execute. So you can execute by just clicking execute.do. So you could see it's being executed. This is like I've started the do file. So do file being executed. This is the path in which the file exists, and from do file it would be executed in the data format. So there's the way in which you can just write the do files. It's like syntax for the operations, and then execute that directly from the do file itself, even without looking at the data. You can also you can also save these commands by clicking them
डॉक्टर सुभाष, आपकी आवाज नहीं आ रही है। सुभाष जी, अच्छा, सुभाष जी का इंटरनेट कनेक्शन इंटरप्ट हो गया है बेसिकली। जब तक वो ज्वाइन करेंगे तब तक आपके क्वेश्चंस है कुछ कुछ हम उनको कलेक्ट कर रहे हैं। अच्छा होगा, it will be better if we put all, we will take all questions at the last of session. Now till that Dr. Subhash SP comes, we can switch to next lecture, that is on R. And for R, we have expert Dr. B.N. Mandal. He is senior scientist at Indian Agriculture Statistic Research Institute, New Delhi. Sir, I request you to unmute yourself and start your lecture.
Dr. Nikam,
yes,
thank you very much, but his lecture is finished.
It's not finished, sir, but we have lost his contact.
Okay.
Last again, we will take that part. You can start with ours.
I can start?
Yes, sir, you can start.
Okay. Good afternoon to all. Welcome to this webinar series for these quantitative methods in the social sciences. So today we are dealing with the softwares. So second in the series is the R software. So I will try to give you a brief introduction. Just let me share my screen. Yeah, so we have R software, an introduction. So in this software, actually, this is a free software and available free of course on the internet, and you can just download this. This is nowadays a very popular software for statistical analysis, and all sorts of graphs and charts can be produced using this software. So it is also a very useful software. So that's why this software has been included in your training. So I'll cover in this session the following things: introduction, source and installation, basic usage, reading data, then descriptive statistics and test of hypothesis little bit, correlation regression briefly, and R packages and graphics. So our time is very short, so I'll try to make it as fast as possible. You can put your questions and answer in the Q&A, that chat box. Okay, so let us start with the introduction. So you know, R is a software which is mainly a programming language, and that is used for statistical analysis. It is not like a spreadsheet software like your Excel, or it is not like SPSS. You have to write codes like the Stata, but it is purely mainly code based. So you have to write programming language. You have to learn this language, and then you can do your analysis. So learning is initially those who are totally new to this software. For them, it will be little bit of difficult at the beginning, but once you see the codings are not difficult, they are easy, so you can learn it. Now, it was created by two persons from the University of Auckland in New Zealand, that is Ross and Robert. So based on their first name, the first letter of their first name, R, so this software has been named as R software. Okay. And right now it is being developed by a group of people which is called the R development core team. There are a few people who are developing this software and releasing updates over time. So there is a group of dedicated people who are working on this software, and it is rightly being maintained by this development core team. Okay, so why should we learn R? These are the reasons. Number one is that it is free and open source. Okay, it is available freely. There is no license cost. You do not have to pay a single rupee for getting the software. And it is open source software. Those who are very advanced developers, software developer, they can use the code and develop new software from this also. And it can operate on a number of operating systems such as Windows, Mac, and your Unix. So all the operating systems, they support R. And the programming facilities are available, graphical facilities are available, and this software can be extended through new contributions. So that is also one more the last point is very, very important, that one can extend the package, this software, by contributing to this software. So where to get our, let us go to the website. So this is the name of the website where you can go get the software, www.rproject.org. Okay, so here let us go to the website. So this is the website where you can get the software freely. Okay, and there are many things in this. This is mainly project. This is a R project for statistical computing. So you can see many things are available, but to get the software, you have to just click around here to download R, this one. Okay, you just click here to download R. You just click here, and you will get a number of mirrors or servers. You can get to any of the place. Suppose I go to the nearby, say in our Malaysia, there is a server, Malaysia here, suppose. But all of the links go to the same page. So they are just maintained servers in different countries. So you can go to any of the country. Better to choose one which is nearest to you. Okay, which is nearest to you. So just go there. And so this is the page where you can get the versions for different software. So for Windows, you have download R for Windows. Then we have download R for Mac and download R for Linux. So because most of us are using Windows software, so you can download this for Windows version as well as for other versions if you have, depending on the operating system that you are having in your machine. So you can download this for Windows version. You can download this. So I will not download it. You can download at your leisure time. I'll show you what file you will get once you download this. So I have already downloaded today. So this is, you get this file. Okay, you get this file R 4.0.0. This is the latest version as of today. Okay, so today, 1st of June, see at 1:15 I have downloaded for this session R 4.0.0. So once you download, you can install this. So for installation, you have to do nothing. You just double click this one and it will install. So it will open this screen, and then yes, click the English, then next, 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 and next, and next. Okay, so create a desktop shortcut if you want, and then next. So it will install. So installation is very, very easy, and you need not have to just pay any price for this. You just simply get it from the web, and then install this, the desktop version. So let it install. It will take just 1 minute, and after that we will be showing you the actual software. Finish. Okay, so once this has been installed, it will be appearing here in the list of programs. You can see this R here, R folder. You can see, sorry, R folder here. Okay, so in this left side, already I had in my system 3.7.0. Today I have installed 4.0. So you can install multiple versions, earlier versions as well as the latest version. So let us open this. So 64-bit version I'll open. So click it. So this is the screen that you get once you start the, or double click that icon. So what are written here? This is our version 4.0.0. It was released on 24th of April this year. Okay, and this message will appear every time you launch the R software. So this is just a brief message. It is a free software, comes with absolutely no warranty and those things. So, and these are the certain menus, but menus will be rarely used. And this window, which is here, it is called console window. You can see the message here, R console. Okay, R console. So in this console window, you have to write the codes here mainly. See, rather than symbol here, you have to write the codes here. So all the codes you have to write here. There is no menu driven things like analyze that, analyze this, mean, no, nothing. You have to write codes here, and that's how it works. But we will not be using the R as such. We'll be using another IDE. So I'll show you that IDE. That is R Studio. Okay, we have this software which is called R Studio. So just start it. So again, I will install this. So let it install, and by the time it install, I will show you where you get the R Studio. So R Studio, you can get it from rstudio.com. This is a company, but it also has see R Studio. These are the product. This is the company. So R Studio download here. If you go, both free version as well as the commercial version. So these are the various products that they are having. R Studio Desktop, that is free, and that is what we'll be using. That is the IDE. Very useful editor is available for using the R, and that is the most popular IDE used for R coding or using R software. Okay, R Studio is the best one. And there are other versions for commercial versions. You have $9.95 you have to pay per year. R Studio Server is also there, free version, which is to be installed in servers. And for Server Pro, for bigger companies, like they can pay this much up and then they get. But we'll be using our desktop, and you can download it from here. Okay, so you can download. So that is the file that I have downloaded here. So it is completed. Now we'll be going to the again R Studio. See, this one is the, I'll show you the R Studio again. So this is R Studio. Okay. It will start, and then you can use it. So here is the screen that also can be used. Yes, it is starting. So when you first time just open this software, it will look like this. I am showing you from the beginning. Okay, so these are the 4 windows you will see. So 1, 2, 3, and 4. So these are the 4 windows you see. Top one, this top left. Okay, this top left window, this window is the console window. This is the this is the console window. Lower one, this is the editor. This is editor. Okay, you can see the name here. This is editor. You can write codes here. You can write your the codes will be written here, and they will be processed here. Results will be appearing here. And this is the environment window. And here you have multiple tabs. Okay, multiple tabs are here: files, plots, packages, and so on. So you can see. So in the file, you can go to the escape. You have to go to pointer. Yeah. So in the files, here in the file window, you can see these are the various files in the home window, the folder that is there. Then plots, here plots will appear, whatever graphics that will be produced. These are the packages. I'll tell you what are packages. Nothing is there right now. And help window. So these are various helps to introduction to R and writing R extension. So we'll come to this later by then viewer, any specialized application. So let us start using R. So we have to now use this R Studio to write the things here. So we'll be using for writing the codes. Okay. So now let us go back to the slide where I was. So I have already told these things. So installation I have said. Using R I have said. Interface we have already seen. And then this is the R Studio. Here is that top one. You can write the codes here. Those will be executed here. Results will be produced. And this is the environment. You can see what are the things available, and these are the packages and other things. So you'll see just very soon. Okay, let us now go to basic. Okay, I will not follow the slides. I'll go directly here. So to start with, you can write in the editor. Suppose you can use the R like a calculator to be starting with. For example, 20 plus say 30. So here, once you write something, you have to click on the hit button, run. Okay, hit the run button. So you just click on the run, and then the result will be produced here. See, 20 plus 30 is equal to 50. So this is the console window where the result will appear. So this is the cursor, and this was the code that we have written. Like this, you can run any of the things. So you can multiply, you can say, sorry. So you can say 30 minus 20, you can again run it. So it should give 10. You can multiply. So all the operators, addition, subtraction, multiplication, division, all those things will be happening. So that is not a problem. Now let us go to variables. Suppose I want to create a variable. Say instead of just working with numbers, suppose X is some variable that I am creating. So variable X I am creating. And here you can use, suppose X is equal to 10, I want to write. That means X is having a value of 10. So once we click on the run button, so let me just, yeah. So here X is equal to 10, nothing is produced, but X is 10. Here in the environment, you can see this object X has been created, which is the value 10. Okay, you can create whatever the objects that you create, those are available here in the global environment. You can see which are the data, which are the variables, those are created. Okay, so now suppose I want to do some operation on this. Suppose I want to find the X square. So X square, like that. So X square, if you run, so it will be showing X square is equal to 100, right? So similarly, you can have another variable, say Y is equal to say 20, and then you can have X plus say Y. So Y is 20, you can run it, and then X plus Y, so result should be 30. So X and Y, two objects are created, and you see the result here. So like this is like simple calculator, and you can use complex expressions like this. So X plus Y square plus twice say Y minus say thrice of X divided by 4, like this. So that will also be evaluated and the results will be produced. So result is 932. So this is a simple usage of the R. Now let us come to the more advanced usage, like say creating a variable with multiple values. Suppose the height of people or income of people, say 100 people, and their income you want to load here, or you have a data set you want to import. So let us go to, because we have very short time, I cannot go into deep. So I'll just try to show you with the help of one data set. So we have a data set here in the desktop. I have one data set. Suppose iris file is there. This is a data file, text file, where there are 4 columns are there. Okay, sepal length, sepal width, petal length, petal width, and species. So we can import that data into here. Okay, so how to import? So for importing, you in the right side you can see import data set. Okay, before this thing, if you want to remove these variables, so you can clean them. So cleaning is possible by this broom button. Just click on the broom button and all the objects will be cleaned. Now let us import the data set. Now what kind of data file you have? Prop, text file, Excel file, SPSS file, SAS file, or Stata file. So our file is text file, suppose. So from text, and then you select the file where it is available. So in the desktop, I have the webinar folder. Inside that, I have the iris data. So I just click on open. Okay, so this is the window. You will see what is the dataset name you want to give. Suppose I want to give the name dataset iris, and this is the input file. This will be the data frame file. Okay, and row names are there automatic, so it will be taking automatic if row headers are there. Header is true, that's why the row names will be automatically. First row will be taken as the variable names. So import. So as a result, this dataset is imported, and see here in the environment you can see this iris object. Okay, and these are the variables you can see here. Now let us suppose I want to do some analysis on this iris data. So I have the iris data here. So I can always see the iris data directly by clicking on run. So these are the values you can see. What are the variables? What are the things available here in this data set? Now to have summary statistics, so we can have simply what now most of the work on the R, they will be done using some function. So functions I have not yet used, simply operators I have used, addition, of subtraction, multiplication, division and other things. But now we can use the functions, okay? Functions. So most of the things will be done, most of the analysis, they will be computed or done using the functions. And what are functions? Functions are some objects which can take some input and they can produce some output. So R is nothing but a collection of various kinds of functions only. It is a collection of various, mainly it is collection of functions. So all the work that are done in the R, they will be done using functions. So for example, suppose I want to have the summary statistics or descriptive statistics for this data set. So my function will be simply summary. So summary, and you have to give the input. What is the input? Input is our data set. So iris is our data set. So I'll just write summary iris and it will just click on the run. So you'll get the summary statistics here. You see, what are the summary statistics you get? You get minimum, first quartile, median, mean, third quartile, and maximum. So these are all the 5-number summary. That is minimum, first quartile, median, mean, third quartile for each of the variables which are numeric. Species was not a numeric variable, so it will give the number of times a particular variable is appearing. Say I setosa observation is appearing 50 times. These are species names. So I versicolor is appearing 50 times. I virginica is appearing 50 times. I will answer all your questions at the end, but first let me just complete my lecture. Then I'll see the questions one by one and I'll answer, because if I take questions right now, the other things I'll miss. Okay, so just bear with me. Then now suppose I want to have simply, instead of having summary of all the variables, suppose I want to have the average of only suppose this particular variable or particular 2-3 variables. So suppose I want the average of the sepal length. Sepal, so length. Okay, this is the variable name LENGTH. Now you have to see here in the global environment, you cannot see the sepal length here. It is inside the iris dataset. So for that, you have to either write iris and then write a dollar symbol here. Okay, just focus on here. I have given a dollar symbol, name of the dataset. This is iris, and this is the variable name sepal length. Okay, this is the dataset name. This is name of the variable after dollar. So if you want the mean of that or average of that, so you will use the function mean iris and then here. So if you just run this line, you will get the variable name is sepal underscore dot, I think. Just hold on. Okay, capital. So R is capital case sensitive, so you have to be careful with the name of the or letters, particularly whether it is small letters or capital letters. So S was capital sepal length here, so that's why you have to just use the capital S sepal length. Okay, so then it will give the result. So this is the mean of the particular variable you can get. Likewise, you can get the variance. For variance, you can get variance of this thing. Okay, this variable, say variance, you can get the variance, and similarly you can get standard deviation for a variable. Then you can have the minimum. Okay, then you can have the maximum, you can have the median, you can have the quartiles, you can have the quantiles, and so on. So there are a lot of functions. So these are all nothing but functions to get the summary statistics. So this way R works. Okay, I hope now you are clear what is the way of R works. And now let us go back to the slides. So once we have got to know about the things, so most of the functionality in the R is provided through the inbuilt function, those functions which I use right now, mean or variance or minimum, maximum, standard deviations, quartile, median, quantiles, all those are inbuilt functions. Those are already available in the base R which I have installed. But there are certain functions which you can create. Those are called user created functions. For example, I can create a function using already available functions. So those are called user created functions, and R has that facility that anyone can create a function to do his analysis according to his way. There is some specific way he wants to do something, some input he wants to give and some output he wants. So he can create a function which according to his choice. So that is called user created function. And all the data objects are kept in the memory during an interactive session. For example, we have loaded the iris data set you have seen, and that iris data is kept in the memory, and that will be used when the R is on. When you just quit the R, the data will be gone from the memory. But there are facilities to save that data object, so I will not go into that right now. And basic functions are available by default. There are many other functions which are not inbuilt, but they are available in the packages. So packages are external functions which can be loaded when you can load the package. Suppose you want to do some specific analysis, so then you can load a package for that, and then you can use the functions which are available in those packages. For example, now I'll show you the use of packages. For example, suppose if you want to load the Excel file or read an Excel file. So how to read that Excel file? So though in the R Studio you can read the Excel file directly, but in the basic R you cannot, because that requires a package. So you will select the file. So I'll go to the desktop, and in my folder I have this, suppose this iris file XLSX. Okay, this one. So open. So it will read the file, and these are the same file I have created, the Excel file. So it will be creating the name iris again. So see here in the code, you can see the code which is being used to read this data. It is creating library read Excel. This read Excel is a package, and that is used to read the Excel packages or Excel files. Sorry. So when loading a package, you have to use the library name of that package. So read Excel is the name of the package to read the Excel file, and this is the code to read Excel file. So read_Excel, this is the location of the file, and iris.xlsx. Okay, so library read Excel, iris, and view. So it is viewing here. So import. So that's why now you'll see in the packages you will have the read Excel package. This is the list of packages that are available in my computer. See, it is loaded. This box is checked, means we have loaded this package in this session. Suppose I want to use some other package. Suppose they combine multi-dimensional arrays. So you have to then load this. And to see what are the functions available in a package, you can go to that particular package. For example, suppose in the read Excel package, let us go. So click on that, and you will see the list of functions which are available. So this is the function that we have used, read Excel. Okay, it opens the documentation of that read Excel command. So read Excel, this is the usage, how to use it. These are the various input that you have to give. Read Excel, path. Okay, read Excel, path, worksheet name, range, which data you want to import, column names are true or false, column types, and so on. So these are the various things which are available. All of these inputs are not necessary, only few are mandatory. So which are mandatory, you can see the details from here. See some examples are also given. and you can see which are mandatory. Say arguments. These are inputs are called arguments in the R language. So path to the file, sheet to read, say worksheet 1, worksheet 2, range to read, column names to read, and column types. These are the things available. Okay. So for any kind of function in the R, you can always get the help. For example, suppose if you want to know the help of mean function, so you will write simply in the editor, you will write suppose say mean. So question mark mean, and then you just run this line. So it will open the help page of that mean. So see the mean, arithmetic mean, this is the usage, and this is the arguments, and these are the some examples. Okay, so you can read the details of any function from the question mark and the name of that function. Now you have to know the name of the functions to do various analysis. That is the job. And those who know the names of the functions for doing various analysis, they are the R experts. So once you start using the R, only thing you need to do is that you need to know the names of the functions for various analysis. That's all. And you have to know them. And lots of helps in online and Google, anywhere, they are available. So it is now easy to learn the R software. I have given you the how to start with. So you have to start like this. You have to open the R Studio. First you have to install R and then R Studio. Then you have to open the R Studio, write in the editor all the codes that you require. You have to read the data like that and use the proper functions to do the proper analysis. But I'll still say certain things before my lecture is finished, because it is only introduction to the software. I'll not go to each and every part of the software, but which are necessary for you as a beginner. Then as you attend the more and more lectures in the training session, those who will be using R, many instructor will be coming, they will be using R, you will get to know how to do those particular analysis. So I will not go into those particular specific analysis. My job was to just make you introduced to this software. So working directory location is there. Suppose if you want to read a file, so those things are there. You right now you don't know. Importing data I have shown you. Then data management, these are the operators, plus, minus, multiplication, division, this is to the power, these are modulus, logical operators are there, greater than, equal to, less than, equal to, not equal to, or and. So all these operators can be used to logically compare variables and values. These are various other functions, arithmetic functions like absolute, sum, minimum, maximum, square root, log, sine, exponential, log 10, cos, round, all those things are available. Statistical, you have already seen, range is also available. So I have already mentioned about these functions. And now I'll see, now let us discuss about this thing, group-wise analysis. Suppose you have a data, you have already seen how to find the mean, median, and all those things, variance and other things. But suppose now in this data set, we have 3 species. So the mean of any variable gives the average for all the species, not combining over all the species. Suppose I want species-wise mean or standard deviation or quantile or any other statistic for a particular variable. Suppose I want for this Setosa species, what is the mean sepal length. So how to do that? So for that, you have to use a function which is called aggregate. Again, it is a usage of function. You have to use proper function. So aggregate is a function which can be used to aggregate things. So aggregate, which is the variable, we want sepal length variable, LENGTH, and by what we want? We want by species, CE species. And in which data it is available? It is available in the iris data set. And then which function you want to apply? I want the mean of that. So I'll use this function, aggregate function, sepal length. I think I should zoom in a little bit. Okay. So aggregate, name of the function is aggregate. This is the name of the variable which we want to analyze group wise. By species wise, data set name is iris, and we want the mean of this variable. Okay, so let us see the output. See, the output is for iris setosa, the mean is 5.006 for the sepal length. For iris versicolor, this is 5.936. For iris virginica, this is 6.588. So these are the various lengths for various species. Similarly, you can have the standard deviation. Suppose I want standard deviation by species. So you can have the standard deviation species wise, or if you want the total species wise, so you can have the like this. So any function you can use, you have to just use the aggregate function and proper function here and the variable you want to mention. So likewise you have to do. So all the functions you have to use properly. So some list of functions you can see. Already I am saying some of you the functions. There are other functions like by functions, and then you have now these are the regarding summary statistics. Now regarding test of significance, now I will not go to the R studio. I will directly explain you from the slide, because now you know how to use the functions. Okay. So for t-test, you have to use the t.test x comma y. X is a variable, y is a variable. Okay. So here it is assumed that variance of these two samples x and y, they are unequal. But if you want to use the classical two independent sample t-test, so you have to make variance var dot equal is equal to true, and this should be capital. Okay, these are all small letters. This should be capital. Variable names will be whatever is the name of the variable in place of x and y. Suppose if you have the height and weight, so you can write like height and weight, or like that. And for paired t-test, so paired is equal to true. So this way t-test can be done. So usage is very simple. See, codes are very one line code only, and the most of the codes are the method is.
Sir, you are not audible, sir. Can you check your mic?
You can see the details of in the help also. Say plot x comma y. I'll show this because this is plotting. Plotting part I will come anyway, but let us go ahead. I'll come to plot later on. So this is not. This is the function, linear model, this one. Linear, this is the name of the function, LM. Okay, and this is the dependent variable, y, and x1 and x2 are independent. If you have another variable, you can write x. These are dependent variable. Okay, so LM, linear model, and the output object. Now in the R, I need to tell you one thing. Any object, any analysis that you do, output into always save into group means. So the result is saved here in the group means, and if you go to the environment, you can see group means object is created. So now what is the content of group means? You can write here simply group means. So see, the output is the same content which was the output here. Okay, so any output of this, any functions, they always can be saved into another object. Okay, so summary result if you want to save, or mean you want to save, or variance you want to save into another variable, so you can always save into some another object by giving a proper name. So that is always available. Okay, so here in that linear model, regression model, so once you feed this model, you can save into the result object, and then you can have the summary of the result. So you can get the summary of the model fitting, and you can have the ANOVA table also, ANOVA of the result. So this way you can use the R for linear model fittings. Now I will come to these charts and graphs. Okay. So for charts and graphs, the basic function that is there available is the plot function. Okay, plot. Now plot what? X comma y. That means in the x-axis you will have the x variable. In the y-axis you will have the y variable. So you have to give proper x and proper y. Suppose from the iris I want to give, say, sepal length. Suppose I want that iris dollar sepal length, and then iris dollar sepal white. Okay, so these two I want to plot. Let us see the plot. So run it. So this is the plot. This is a scatter plot. Okay, this plot that is produced here, this is produced automatically in the plot window. So window here is plot. Okay, so this is the scatter plot between the two variable sepal length and sepal white. You can see the points. You can make them colorful if you want. So you can put a color. Suppose color is equal to, say, blue. Okay, so it will be appearing in blue colors. So the points have become blue. If you want, instead of circle, some other characters like plot, and what are the details available. So this is the plot function details, and these are the graphical parameters are available. See, the plot function basic usage is x comma y less than dot dot dot. Dot 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 means lines. So L, if you want both line and point both. Likewise, similarly, other graphical parameters can be put. Other arguments like title, if you want to put a title here. Suppose I want to put title, say scatter plot. CATTR, scatter plot. Okay, so oh, it is not title, it is the main actually. Main. So the scatter plot has come. This title I have just used, the argument is main. If you want, instead of in the x-axis iris dollar, if you want x lab, so you have to plot, suppose x lab is equal to, suppose only I want to write length instead of, and in the y lab means labeling of y, labeling of x. So here it is white. So see, it is now length and the white. So likewise, any plot can be modified by seeing the all the arguments that are there, by passing all the necessary arguments. So there are a lot of arguments available here. Graphical parameter list is too big, and that's why the charts can be very flexible, and the way you want you can produce. So many number of graphical parameters are available. What I was trying to show you, suppose I want a square instead of circle. So there are PCH is there available. So plotting character here, PCH, plotting character points. You have to go through the details because R is very big. So suppose these are the various plotting characters available for boxes like 0. So for solid circle 90. So if I use here PCH is equal to, suppose, say 19, I want solid circle. So what will happen? See, all the points have become solid, not the empty circles. So likewise, you can modify the graphics, but you have to play with the R for doing those things. Okay, it is not a by default system. By default, it will appear which is there, but to modify according to your need, you have to pass through necessary arguments into the plots. Okay. Now I'll go through the other parts in that slide. So likewise, suppose x is like this from 0 to 1 in the sequence of, say, 0.02, y is x square. So if you want to plot x and y to produce a line chart, so x comma y, color is red, type is, suppose, over. O means both points are overlaid with the lines. So this is type O. Similarly, For bar chart, the function name is bar plot. Sorry, the bar plot, and bar plot, the name of the variable. Bar plot of x. Suppose it will give the bar plot of whatever the content of the x. Suppose x contains these 5 values. Here length is the variable name. If you see x, it is suppose. So bar plot of x means these 5 values, 5 bars will be produced of value 10, 34, 21, 14 and 28. Likewise, okay. Then you can go to pie chart, say pie chart of variable x. So that will produce the pie chart. Pie, function name is pie. For histogram, function name is hist, H-I-S-T, hist. And this is the variable y. So, okay, histogram. Now, R package where to get. Okay, so before I go to the ending of this slide, where to get the R packages. Okay, so suppose for packages, you have to, suppose you want to install a new package. Suppose I want to show you. So you have to write here install, click in the install and write the name of the package. For example, suppose for multivariate analysis, I want to generate a multivariate normal say package. So there is a package MVT norm. Okay, so as soon as you start typing the names, the list of packages automatically come to starting with M. You can see these are the packages available. Then as you MV, what these are the name of the packages with MV. So I am typing MVT norm. So multivariate normal. This is used to generate random multivariate normal data points. Okay, so this is the package. So it will be installed. So it will automatically install if you have the net connection with the machine. So yes. Okay, so it will be installed. Within a minute, it will be installed. Okay, and all the packages are also free. They are also maintained in the same R project website. This same website which you have seen already, R package, R software here. In this, you have this, see, in this website, you have the R packages somewhere. So there it is maintained. List of R packages, you can search around here. It is available somewhere. Okay. So it is there. Now, I'll see your questions. So thank you very much for your interest. I know it is because next speaker will be waiting and we don't have much time. So I'll try to answer your questions, what are there. So I'll just close this slide and see what are your comments. Yes. So why Stata is used here? Okay, that is not my question. Thank you. What is difference between Stata and R software? Stata is a commercial software. R is a free software. Okay, and sir, will you share the recording, please? So that is your teacher can tell your course coordinator. Due to network, voice is not clear. That is not beyond my. Have you changed slide? It is not showing how to get into those data set. Which analysis is done by software? I've installed R Studio. For R Studio, first you need to install R. Then you can use the R Studio. Okay, you cannot directly go to the. Okay, I'll stop sharing the screen. Let us now. Yes, so I'll see the questions, Dr. Nikam. Then.
Yes, sir.
Yeah.
We can take questions later on also, sir.
Yeah, I'm just okay. Is the next speaker waiting?
Yes, Dr. Subhash, are you available?
Okay, so then we can take the
Unmute
question.
yourself. If Subhash.
Okay, thank you.
Sir,
thank you.
Dr. Subhash.
Yes, sir,
Unmute yourself.
Yes.
You start your video also. Thank you.
Should I be continuing?
Yes,
with
sir.
the Stata? Yeah, spaces. Is the person for spaces available?
Yeah, Dr. Sab, you can start. Dr. Subhash, you can start. We'll
Vinayak sir?
we'll take questions later on. Now you can start and complete your part. Maybe within 10 minutes you can complete also.
Okay, so sorry everyone, there was an issue with the internet connection, so it got disconnected. So I was about to finish the session. But after seeing R, you might be more clear. Package is how the syntax work. The equivalent of syntax is in R is what Sir suggested as codes. That's the same. So if you see the structure of both Stata and R, they are almost same. The windows and the way they matter may change a bit, but it's the structure is almost the same. Let me show some basic commands in Stata. I hope you can see the Stata view from my desktop now. Like very basic analysis what we do. Let me show it using this command option. As I said, you can go for drop-down options, but some basic command options. For example, after importing the data into Stata or opening up a Stata file, you could see the variables listed here as variable name and label. Variable name is the name of the variable. Label, it has automatically picked up, but we can also rename the label. For example, what like variable name had given us farmer ID and label it's showing as farmer ID same. So I can rename the label as label var, select the variable name or just type the variable name, unique ID of the farmer. So if you use this command, you could see that in the label, you have changed the name of the label of the variable. That's one way of doing it. This is one basic structure thing with, so you can generate new variables in Stata using the command called as gen. So you can generate any new variable. For example, I want to generate a new variable so that, let me show how the variables X is there. For example, other than summarize, we generally summarize continuous variable. For categorical variables, we generally use we can tabulate them. Tabulate is basically a percentage analysis showing frequency and percentage. For that, you can use tab. Sex is here categorical variable. So how to see that? So here it's tab sex. You can see that it's a categorical variable female and male. Normally, so that's it's showing frequencies percentage. This is another summary statistics you generally use in analysis. One more, which is very commonly used. If you want to generate a variable in regression analysis or in econometric analysis, we generally use dummy. So we have to generate a dummy variable with if male is equal to if the variable is male. So I'm trying to generate a dummy for the sex variable. So generating gen is a command for generating a new variable. Gen cx dummy is equal to 0. So what you can do is that you can replace sex dummy equal to 1 if, so this is what I said, like you can add if conditions, like conditions, it could be if conditions, variable sex equal to double quote female. I will explain this part. So if there is some mistake in the command, you would get this red like there is an issue. When there is something shown as red, it means that there is some issue in the command. So after if condition, you generally need to specify it as double equal to. This is a common format across Stata. If after if conditions, anything when we are specifying it has to have double equal to. So you could see now you have a variable called, if I'm tabulating it's tab sex dummy. So I have a variable which is like basically a dummy variable for male. This is one way of generating it. There are multiple ways of generating and working with Stata. There are multiple ways in which people write command. It is own. I won't say this would be everybody have their own style, but there are more efficient ways of actually running the commands in Stata. Some basic analysis what we do are in economics is economics or in generally in social sciences is regressions and correlations. So if you want to run regression between two variables, it's pretty easy in Stata. It's like let me start with correlation. If you want to run correlation between two variables, it's the command is pw core. So we do generally run correlations between continuous variables. So I have two continuous variable, age and education. So if I run it, I could see the correlation between them is minus 0.4839. If you want to get the significance, you can put the command ~sig. You could get the p-value here. This is basically significance. How I am and like once you get used to this command, it's easy that you can. It's like a language. You'd start typing down what's there, how it's to be done. But for a beginner, if you want to search how to do a correlation, very simple way is that just go to Google and type how to do correlation in Stata. There are like enough. For example, let me just show you. For any basic statistical command, you can just type Google how to do correlation in Stata. You can get enough supporting videos as well as materials. So one which I would like to show you is that UCL has a good material on Stata, which is pretty helpful. So which is it's very good and easier to follow from the UCL website. This is a good resource for learning how to work in Stata. These are the basic operations which I wanted to show. You could explore further, and experts would be further sharing how to do those individual exercises using Stata. They'll be sharing the data sets either in Stata or in Excel. They might be sharing do files, or else they'll be demonstrating how to run the command in the Stata command windows or executing statistical operations using the drop down menu. If you have any specific questions, you can drop a mail. I was trying to answer the questions in Facebook Live. I couldn't do that. I've responded to a few questions in Zoom chat. So let me share my email ID. If you have any specific queries, please drop a mail. This is my email ID. That's from my side. Thank you.
Dr. Subhash,
Yes.
complete, huh?
Yeah, I'm done with my presentation.
Okay, now we can take questions and answer till next panelist comes. Dr. Mandal sir, you can answer some of the questions.
Yeah. So I'll see the question answers. Which Dinesh Jamar Katel says, I have installed R Studio, but it doesn't open at all. So what happened there, I cannot see, but you have to install R first, then R Studio, because without R Studio cannot work. R is the main part, main engine. So R should be there. Then only R Studio can be used. Okay, sir, can you please show calculation of CAGR and CV using R? Okay, that is CAGR is annual growth rate, I think. And CV is, okay, this thing can be easily done. I think next of the speakers, those will be coming for specific topics, they will discuss these things. But CV is simply sigma by x bar. So standard deviation of x divided by mean of x into 100. That's the thing. So easily it can be done. So that is not a problem. Which kind of the file most convenient to make? I didn't get the question. What kind of analysis to be done in R? Okay. So R does not limit analysis type. So you can do any kind of statistical analysis or numerical analysis in the R. So it is now extended to all the domains. So it is being used in across the domains, not only in statistics, in all kinds of numerical, wherever numerical things are there, numbers analysis are there, they can be used. Okay. Chandresh Guleria, R is case sensitive. So do we have some directory of commands, codes that we can use? You can get a list of those called cheat sheets. That means R, they are called R, what is called the one thing there. In one page, you have all the basic summary. R, that is, there is name is there. Cheat sheets type, R cheat sheets. You just simply search in the Google, you get a most commonly used list of functions. How are software better than Excel statistical analysis? Excel is a spreadsheet, it is not at all object oriented. So every time you have to open a separate file and do the analysis. But R is in one go, you can handle multiple data sets, multiple files, as well as create new files and new objects from multiple data. So that is, it is different totally. It is not Excel type. Sir, sometimes particular package is compatible for particular version of our software. I mean it compatible to lower version. See, always try to use the latest version of package as well as the latest version of the R software. Then there is no problem. Always there will be compatibility issues. If you use a say older version of R and a package which has been built in a newer version of R. So there will be compatibility issues. You can always update the R. It is freely available. So every 6 months or so, you can update you in your machine. So that is not a problem. I am facing problem of version of file in opening of RStudio. RStudio is not open, I think already answered. How can we order the data and give them rank according to some column? It's a specific question. So I like to answer only the basic R related, introduction related questions. So computations can be easily done. You just simply use order function to just order the observations and you can rank them easily. Okay, which kind of file is convenient to make and handle? Okay, any other? I think these are just comments type. What kind of variables do we generate in terms of Tobit regression model? Sunish Sharma. See, I have no experience of using Tobit regression model, but you can see the help available online as well as in some books which deals with Tobit. I think GLM package should be, GLM function should be able to handle it, because generalized linear model, any kind of generalized linear model, whether it is Logit or Probit or Tobit, they can be handled in the GLM functions. You see the GLM function help. Okay, sir, is there package option available in Stata like R? So I think Dr. Subhas will answer that. I'll try to answer. Okay, I think these are the common questions that are there. How can we analyze time series for whom it is not released? Time series can be handled. T series package is there for that, for handling time series data in the R. And there are many other packages as well as not only the T series, there are zoo package, there's a ZOO. So that also handle time series data. So you can see all those things. Okay, thank you. Any specific other questions if you have, you can type immediately. I'll be happy to answer. Dr. Nikam, you can hand over to Dr. Subhas.
Yes, Dr. Subhash, you can answer your questions, some of your questions.
So, so I'll pick the last question. Which one is good for new students? I would definitely recommend R. It's that's one because for students it's free, open, accessible. R like a lot of things happens behind Stata which is not visible. So we don't know what's happening behind. So it's like in Max using different calculators. So it's good to know the steps. So R gave you the chance of actually doing this analysis, knowing how it's being done, what's running behind the background. That's good for students, and of course it's free. But it's also good to have a basic knowledge in Stata. For students, I would still recommend you should have a brief idea about like across different platforms. You should not be very Stata analysis or platform dependent. That's my view. I've responded to all other questions in the text. If any specific questions are there, please drop me a mail.
Yes, Dr. Subhash.
Yes.
Very much for answering the questions. I think our next panelist, Dr. Arpan Bhumik, is not able to join. Again, if possible, my request, Dr. Subhash, if possible, you can demonstrate SPSS within 10-15 minutes. Just basic introduction of SPSS, Windows and other commands.
Okay. So again, I have an older version of SPSS.
No problem, Dr. Subhash.
So again, the same. Please download. You can go to Google, type Google. You can type in Google trial version of SPSS. You can get a trial version of SPSS. Download it. I think it has a period of 30 days. As far as I could remember. Let me share my screen. Basically, like when you open up the software. So in SPSS, there are two windows. Like if you had seen the structure of R and Stata somehow similar, there are different windows which does kind of similar operations. But in SPSS, it's a bit different. So this is how an SPSS file opens. It has two windows. One is called as data view and another called as variable view. So data view is where data is shown, and variable view is where like it's similar to that of properties and variable window in Stata. So you can might want to show like here you can define variable here itself.
Dr. Subhash? Dr. Subhash, you are not audible to us. Can you check your microphone? Till then, Dr. Mandal sir, you can take any questions till Dr. Subhash can join.
Questions, wait. Yeah, but questions are not there, anything, I think, special. Only comments. Let us see. Okay. Yeah, sir, will you refer some names of data sets in R for ANOVA model? Name of data sets. In R, there may be many. If you type the data comment in the R Studio, then you get the names of all the list of inbuilt data set in the R. So you can go through those lists. That is a big list. So I have never seen entire lists. So there may be, for example, plant growth, as I remember. So that is a data set related to growth of plants with some treatments. So that data set can be used for doing the ANOVA, means for seeing the example of ANOVA. But you have to write the codes. Codes are not available there. Only data set is available. So data command gives the list of inbuilt data. Okay, data brackets, open brackets. So, sir, how can we predict yield of crop using R? So that is a modeling question. So that has to be addressed through modeling based on the data. This is a general answer. I cannot give a specific answer here because that depends on data, and that depends on the data you are using, which data you are using, which crop data you are using. So you have to go to the specific. Okay. Then, sir, how can you use non-parametric analysis in R? Yes, there are, Alok Kumar Sahu. There are many non-parametric methods are also available. Sign test, then rank test, and all those things. Wilcoxon test. So list of functions are there for doing the various non-parametric tests. So you can go through them. Okay, you just search in the Google non-parametric test, you will get the list of functions. So that is not a problem. What kind of econometric analysis should we do in the R software? So the next sessions in the coming days, they will be dealing with specific econometrics things. I am not an expert of econometrics, so I will not be able to comment on that. But you go through the list of the packages by names which handle the, you can see which are the things for which type of analysis. So you can see the list of packages there which deals with the econometric problems. Okay. How NSSO or okay. How can I get factor loading coefficient in PCA using R? For PC analysis in R, you can use PrimComp or PRComp functions. Two functions are there. So if you see the help of that PRComp, okay, function, you can get the details. So that is not loadings function is there. I think inside that the object will contain all the things, loadings as well as scores, as well as the eigenvalues and all those things. Yeah, these are the questions, Dr. Nikam.
Okay, thank you very much, sir, for very good explanation of the software as well as this very nice question and answer session. We have lost contact with two experts, Dr. Arpan Bhaumik as well as Dr. Subhash SP. Maybe Subhash SP's part is complete, but this SPSS part, if the participant demand, we can have one more session, maybe 30 minutes in any time, as per convenience of the participant, they can tell us. Now we'll stop here. I request all participants, whatever the software that today we taught, Stata spaces, particularly Stata and R, this software will be used in subsequent lectures because this expert will demonstrate you practically in these softwares only. Then therefore I request you that you be convenient with all this software. And once again, I thank you all participants for joining this meeting. Tomorrow we will start with composite index, construction of composite index by Dr. Premchand sir. We'll meet at 4 o'clock. Thank you very much.
Thank you, Dr. Nikam. Thanks to
Thank-
all the participants from my side also. Thank you very much.
Thank you, sir.